Good morning, everybody. So just to cross check that, can you hear me properly and can you see my shared screen? Okay, great. So let us wait for a while so the rest of the people also join us and then we can start. Okay, so I think we should start. I am not sure if anyone else is going to join us. Okay, uh, so just to cross check one more thing that
Yes,
the last
Aamir.
section was somehow cancelled. Is it correct? And we have to go for session 7, which is data visualization, right? You didn't have this session before. Okay, okay. So basically, we'll try to cover data visualization, and the most important thing is that we have been doing and applying some functions on pandas, numpy. We had seen different things which we can apply using these libraries. But think from a perspective of an organization manager or someone who has to make decision. So we were applying different uh, functions on matches data and different data sets, and we were fetching some insights. So think from that manager perspective or that person who has to make decision based on this data and the things which we were applying on it. It is much more easy to see the trends, to see the graphs in front of you and then make decisions instead of reading the numbers and tables and everything. For that, we have been always focusing that we will be talking about the visualization using matplotlib, which is like one of the library which we use a lot for visualization. And so basically today this is what we are going to do. And our actually content is made of two main parts of visualization. One is using matplotlib library and the other one is using seaborn. And today we are going to see matplotlib. We'll be exploring different functions which can be used during this library, and for visualizing stuff. So before I continue with it, like just to have a quick uh, chat, like if everything is going fine with the previous things which we have covered so far, any problems in that? My question is that do you have any problem with the existing things, or is everything is fine and we can move forward with it? Okay, good. So basically, first of all, what exactly we do, like as always, we try to import the libraries which we have to use. And for instance, here we are importing pandas as PD, numpy as an NB, and now we are importing another library which is matplotlib.pyplot. So basically, we will be using two types of function here for visualizing stuff. The first one is using matplotlib, and the second one is using the actually pandas library for plotting graphs. And then here is another important thing which says that percentage matplotlib inline. The purpose of this particular line is to render the figures within your notebook. For instance, whenever you run uh, a particular visualization, so it should by default understand that like this is being done using matplotlib, and it will render the image right next to that box or that cell in which your code is written. If we don't do it, we'll have to explicitly tell that okay, this is the function, and using this particular library which is matplotlib, we have to plot this. I'll show you, and it will be much more clear when we'll be executing the graphs. So first of all, just the same data set which we have been using for a while, and just to give it a head that what exactly it looks like. So we have matches, and which is like which match was played, among which teams it was played, and a lot of different attributes which we have in the matches dataset. So, yes, so here's a thing. So for some reasons, this particular line is not being executed here, and which means that if I have to plot a graph, this is what I have to do. Uh, so PLT is the name of matplotlib library which I have here. Here you can see, which means that if I have to plot something, I have to say plt.show explicitly. If I execute this particular line, which says that matplotlib inline, so what actually happen is that I can use without saying this plt.show. Our Python notebook by default understand that what library we want to run for. Uh, oh, what library we want to use for visualizing our data frame. For instance, in this case, if I say dot plot bar, it should use the matplotlib library to to show the plot. So let us go further explore this thing, and let us take an example of for data, and which is composed of 5 main elements, which says that we have array which is composed of just 5 numbers, 1 2 3 4 5, and we want to use matplotlib library to plot this data. So here it is. Give me a second here. Okay, here we go. So as I said earlier that previously we were unable to execute this particular line, matplotlib inline, and we had to explicitly mention that what library we have to use for plotting uh, our data frame. But in this particular case now, we managed to execute this particular line, which means that now we have our matplotlib library inline, and without explicitly mention that we have to use PLT for plotting our graphs, we can simply say just show, or we can call the functions, and uh, um, the Python will by default understand that this is the library which we want to go for, which we want to use for visualizing our stuff. In this case, uh, we have again the data frame matches. We are taking the player of the match, and we are taking the value count, the number of times that particular a particular player become the man of the match. And just cross check, and just to show you that how does it look like. So here we have a player of match, and here is the number of times the player won the the player of the match award. And then we are selecting top 10 rows from here, just to show you. And then the important thing is now we want to plot it. And so there are a lot of different ways to plot this information. Can someone tell me that what sort of graphs do we use on our daily basis, like which you are aware of, that when exactly we have to go for what particular graph? First of all, like what are different types of graph which we can use here? What are the most suitable options for us? Anyone among you? Okay, Uji is saying pie graph, yeah, bar and pie, yeah, true, true. So there are a lot of different things, and we will be seeing all. We will be going through all of them. And so, first of all, let's go for the bar graph. And for the bar graph, the important thing is that like we have a different numbers of the number of times a particular player won the player of the match award, and we may would like to simply compare them among each other. So in this particular case, it's pretty intuitive to have a bar graph here. Let us see that what do we get here. And here in this case, you can see that like by default we have our uh, man of the match and the player on the x-axis, and we have the y-axis, and which shows the number of the time the particular player won the award. And we didn't explicitly mention anything why it is what Python is doing here, how it is knowing that like what should be the particular axis. We'll be explaining that, but just to show you that with just one thing, with just and one extra command here, one extra function, we can now plot it in front of us. That is the beauty of matplotlib, that it gives you like a lot of power in terms of visualization. So let us now further go into the detail and take a data thing. Can someone tell me that what should be the type of data here? Anyone? Okay, list. Yeah. So here we have a list, Sandeep, and so there are 5 different elements in the list, and we want to plot it. And here we go. So there are just 5 numbers starting from 1 to 5, and we want to plot them. We didn't say that what is our x-axis, what is our y-axis, what number belongs to what particular axis. So in this case, Python takes some default values, and for x-axis it starts from 0 and it goes so on and so forth. And the values which you give as a list, it takes those values as a y-axis and it plots. We will see in a while that how can we set axes, how can we assign some labels and stuff. But just to start with a very basic thing, we have a graph in front of us. Like once we have a list, we can plot it with it. And since in this particular case we didn't mention that what exactly uh, type of line or type of graph we want to have, so by default it takes line graph. We had seen that in previous example when we gave explicitly that we want to go for bar graph, so we had to mention there. So let us move forward. Let us take another example of another list, which is composed of 100, 150, 200, 250, and 300. And it's once again, what's happening here is uh, it is taking those values and thinking that these are the values of y, and for x it is taking the corresponding default values, which starts from 0 and goes on. So in this particular case, the first value is 100. So try to map that 100 belongs to 0 at x-axis, and similarly it takes like some steps in it, and then we have 150 and 200 and so on and so forth, so we get a straight line. Okay, now let us play a bit more with this uh, graphs, and now in this case everything was like default. For instance, like we were just giving the value of y, but now let's create some data. So just to show you, we have a data of a range, and you guys know that like if we go for a range, so it starts from 0 and including the number which we mentioned there in the list, which is 6 here, takes all the values. And now we want to have data square. In this particular case, what we will do, actually we are taking just the square of all the values in the data, and for each value we will square it and return it back into data square. So here is the output of this, in which we have 0, 1, 2, the 2 square, 3 square, 4 square, and 5 square. And next we want to plot it. So what exactly we are doing here? We are in x-axis first. Now we have parameters. So with the value which you want to plot on x-axis, the value you want to plot on y-axis, and your type of uh, actually it's not a type of graph, it's like type of the bullets, the type of your, what is it called, the tick marks. For instance, like in this particular case we don't have any uh, thing like which belongs to that particular index. Let me just show you. It's just, so, and color of those ticks. So here you can see that we went for it, and this is a square graph. So for each and every value, for instance, 0 is 0, and then for 1 is 1, and for 2 is equal to 4, and then 3 is 9. So it's an exponential graph and it's going up. So by default it went for blue color, and this is the thing which we want to use for one particular tick whenever there is a point in our graph. So this is the symbol which we use for that tick. Now let us use a different one. Now we want to use green and using this particular symbol. So this is basically the type you want to have in your line. So how does your line should appear? So there are a lot of different ways, and again you have to consult the basic matplotlib library for this. That how does it, what exactly a particular word means. For instance, the G means green, and B means blue, and it's K means black. So so basically this is just like intuition, like that G is for green and K is black here. So just to have a better idea, again, it's very difficult to remember each and everything. So it's like good idea to always consult the documentation for this. And then there are a lot of other ways in which we can represent our line. For instance, some of them are here. Let me just show you quickly. So now we want to go for red color, and this should be the symbol of our text. So is it clear so far? It's pretty easy stuff and pretty like naive stuff, but do let me know if you have any issues so far. Yes, please, Akshay, go ahead. Okay, it's a very good question, how to get grid in the background. Fortunately, we are going to cover this thing in today's lecture. So there is a way in which we get a grid, in which we deal with axis, that where to put our axis. But I would like to wait. I would like you to wait a bit until we reach this stage. We are going to cover this thing in today's lecture. So any other questions so far? No question. Should we move forward? Just respond my question so I can sort of an idea that like we are following me and we can move forward. Okay, good. So in this particular case, so far, what exactly we were doing, we were just giving a list to Python and asking Python using matplotlib library to basically plot the graph. We didn't say that what should our axis look like, what are the main parameters on which it should belongs, that like how long should be our x-axis, how long should be our y-axis. So when we talk about the real graphs and real plotting, we always have to explicitly mention it. And it's like somehow our requirement. It's a good idea that Python take care of this thing. For instance, in this particular case, we are taking this care of 1 to 5, so it has all of these numbers till 5 by default. But we may have different requirement. For instance, I want to start from 0 and I only want to keep till 8, or and then for x-axis, and for the y-axis I want to start from 0 and go until only 30. So in this particular case, the first value is x min, and the second value is x max, and the third value is y min. The fourth one is the y max. So here now you can see that we are for x-axis now we wanted to go for up to 8 values. So we have some extra space here. We can have last one as well. For example, let's go. We want to go for only for 4 values. So in this particular case, now we have only 4. And for y-axis, similarly, we can go for. We can change the value. We can say that okay, we only want to have this part of data in our form. So or another case, if you want to have some other extra space in your graph or some other stuff, so you can always mention that how big should be your axis and how big should be your graph. So when we talk about usually line graphs, in most of the cases, basically line graph is to know the trend, how your data looks like. But in a lot of the cases when we have to compare multiple things together, so what we try to do is that we usually plot multiple lines on same graph. We can do it using we have been using it actually, I believe all of us, for Excel, and we have been using these multiple line graphs on a single graph. So let us see that how can we do that. How can we plot multiple lines in a same plot in a same graph. Once again, we have to take some data as an input. Let me take an range. Yeah, np dot range. So it's like just a numpy array and the range function for that. So can someone please explain me that what is going on here? Uh, what are these parameters? Can someone quickly show? Okay, so we're just saying that it's like increment 0.2. Yes, true. So just to remind you that it's starting from 0, it is going until 5, but not including 5, and the increment here is 0.2. If we don't have this increment, so it's not 0.5 Vijay, it's still 5 actually, 5.0. So if we don't have it a stepping size, then by default it goes for 1. So we have created this list of these many numbers starting from 0 to 4.8, and next we want to plot multiple things here. So what we will do here, will even in case we want to have multiple lines, we can go for the same function, which is plt.plot. But in this particular case, there is an order of the parameters. The first parameter is an x-axis, which we said earlier, which we had seen. The second parameter is the y-axis, the data which you plot based on your y-axis. Then we have the color of your text, and then the type. And this is one line so far. For the next case, it will start. If we keep on adding some more stuff, it will by default be assuming that there is a new line, and this is the x axis, for that particular line, and this is the data which we have plot using y-axis, and this is the type of text. Similarly for the third, for instance here, so what actually we did is that we use t, which was a list of elements we had seen, and then we plot three main things. The first one was that actual the value, which should give us like a linear graph. Let me show you that how it looks like that if I only plot one. So it was the linear line, and then we had another value which was square of it. So here we are. So now we can see that like that we can put both of these two lines in one plot, and we can see and try to compare that how the value changes among a particular value of x. And similarly we can have finally the other value which is of 3. Very important thing here is that when I only plotted one of them, one line, so there was a different y-axis. And for instance, let me just show you again. So here it is going up to sorry, it should be here. So here, look at this. Now the y-axis was going up to 5 because our maximum y value is 5. So Python take care of this by default, but when we have all the lines which we wanted to have, so it will update the y-axis accordingly in this case. So here we have all of these three graphs, and we use them for like comparison or any other thing, whatever we want to have. We can do a lot of different tweaking with these lines. We may want to increase the length. We may, as we are saying, we can change the type of the text which can appear there. We can change the color. And in this case, let's see that we want to uh, increase the width up to 5.0. So here you can see that like in this particular case, we simply increase the width of line. Again, just to cross check is everything is going fine. I think so far it's pretty naive and pretty easy. We'll try to do some hands-on today, but depending on that how much overwhelming it is, we can decide that if it should be in today's lecture, or you just have to do the assignments. But is it clear so far? Okay, good to know that. So whatever we have plotted so far, the issue was that okay, we were plotting some lines. We had corresponding suitable x and y axis, but what that particular x belongs to. For instance, in this particular case, we have 0 to 5, but it's not really intuitive, or it's like uh, not really informative in a way that like if someone is looking at this plot, he may not understand that what is going on, what is x-axis and what is y-axis. So most of the time when we do plot something, when we have visualization, we usually go for x labels. We go for the title of the plot to explicitly show the intuition behind that particular plot. And in this case, we'll see that how can we have x and y labels and the label and the title of our graph. So here we have some of the functions. The first one is says that plt dot title, which says that so let me just simply first plot it and then show you using that plot. So here again, once again, we were using the same data, which from 0 to 5. Then data square of that data list. Another important thing which I have missed here is that here you can always create a new list for the square and the cube of your list. But rather than having a new variable and doing it and separately, what we did here is that we simply took the power while plotting it. So we can tweak with our list like on the fly, and do whatever we want to do in this particular case rather than having a new variable. But it's always possible to to create a new list which is composed of square and then give it as a parameter. For instance, this is what we are doing here. We had taken in this particular case data square is the square of the list of data, and we want to have a title of a graph which is the square of numbers. It can be anything, it's just a name. So and then we want to have x label and y label, which is for x label we have number, and for y label we have square values. So we simply give the names and simply run it using this particular function. You can always update it. Okay, so this was the question, that how can we use grids in our plot. So again, thanks to the Python, we have a lot of such functions which they require on daily basis. So in this particular case, by default, the grid was false and we were not getting it. But then once you do it true, so you can have the grid, the backend of your plot. You can change the size of grid. You can change how it should look like, and but then there is a lot of different functions which different parameters which belongs to grid. You can always go and look into much more detail that what are the different functions which can be applied on function grid, and what are the different parameters, and to further have different types of grid. So again, we are not doing much different here. We are taking a list of data and another square of those all the items in that particular list, and we are trying to plot it using line graph, because we didn't explicitly mention that what sort of graph we want here. So by default it is going for line graph. And then the only thing which we added here is that we wanted to have grid at the background. Let's see that if we want to go for false, which is actually by default value, so we don't have the grid here. So if you really want to have, just go for it. Can someone tell me what is annotation in the plot? So this is a question for you guys. Uh, that what is to annotate, and why do we use it? Maybe a little more thing in my question. So we're just saying it's indication, but why do we use it? Any insights? Any answer on that? Okay, yeah. So through a lot of answers. Okay, that's good. At least that everyone is active and following us. Good to know that. So actually, I actually agree to most of the things which you have said, which is to describe, to point out what the particular value stands for. Yes. So basically, it is something which we want to. So we have like a lot of different values plotted on our on this plot or our graph, and we may want to emphasize on one particular value. For instance, that like we are interested that what exactly the scale of 4 belongs to, or like on one particular value. So in this particular case, let's say that I want to emphasize on this part of a graph, and what I will do is that I will simply annotate it. Once again, this is This is a name, it can be anything. Uh, so just like this. So you can write whatever you want to have at this particular value. At what value? That is important thing. So which says that xy is the parameter and the first value is x and the second value is y. So what it will do, it will go at this particular value, x is equal to 4 and y is equal to 16, and here it will annotate whatever you want to say. So another way of having of controlling the x's is that we can go for x lim and y lim, which is just like x limit and y limit. So in this particular case, what are we doing is we are giving a range actually for x-axis to plot. We again have, let me just cross-check, cross-show you that like what does this data and data scale belongs to, although I'm sure that you have an idea, but just to have. So it's like, yes, so here it is basically these the scale of the list, which is 0, 1, 2, 3, 4, 5. Gajanan, yeah, finally everyone should avoid it. Yes, there is voice. Can you make sure that coming from somewhere else? Make sure that like so this is weird. Apparently, like everyone is on but like please make sure that you have not logged into some like from your desktop as well as here. Gajanan, can you please go on mute? Service. Basically, Gajanan is like this. Is logged in from two multiple. Is it something that from VPN system as well? So, oh my goodness. Uh, Gajanan, can you please hear us and try to mute yourself? Okay, better now? I think like I cannot hear any noise now. So, okay. So again, Gajanan, kindly go on mute so we can continue. I'm not sure if you can hear us. So guys, please make sure that you're on mute or just to cross check like that. So your background noise do not disturb the other people in this case. It's okay, no problem. Please take care of it, like for upcoming sessions and time. So in this particular case, we were looking at the limits of x and y, and we saw we had seen a way to control our x and y axis. And another thing is that if we go for limit, and this particular case, if we do it by default, so Python take it like the list which you have, and accordingly draws your x-axis and y-axis. But now we want to explicitly mention that we want to go for this x limit, and in this particular case we say that we want to go from 0 to 10, so it takes this value for x-axis. And the point here is we still didn't give y-axis, which is uh, so if we didn't give it, means that Python is going to take it by default, and which is it is taking for like up to the maximum value of the one. We can always give it explicitly, which is like this, and now we have 0 to 50. We can change it based on our intuition or based on our requirement, but this is another way of controlling your access. X and Y ticks. Okay. Does anyone know that what does ticks mean here? Okay, so basically it's a question for you guys. Uh, do you really understand that what does a tick mean? What was the tick in this our previous graph, and what is changing now? So the basic answer is that it's an interval between values on x and y axis. Any other insight? So basically here, basically tick is a point at which we want to take a value on our plot. For instance, like here, we were taking basically 5 different values. It's 0, 1, 2, and let me just go to the default axis so it will be much more clear here. So yeah, here in this case, like it is starting from 0 and going to 5. The value of x is maximum going up to 5. So we were actually taking the 6 different values of x is equal to 0, 1, 2, 3, 4, and 5. But why it is not explicitly visible to us? Because it's a line graph, and in the line graph everything is connected among each other. Uh, in a lot of different cases, we are probably we might be interested in much more ticks. For instance, that we may want to have much more points. Let me quickly go up and show you that like what does it mean here. So in this particular case, we had this many ticks in our plot. But what if you want to have it on more interval? Like we want to have something in between 0 and 1 around 0.5 and so on and so forth. In that particular case, we can always control our ticks. Uh, so basically ticks mean that at what particular point at our interval you want to have your data recording in your plot. So here in this case we want to start from 0 for x ticks. We want until 5.25, and the diff interval is 6.25 here. So here we have seen that like now it is giving us for all the values on which it was being plotted. The issue was there, they were like overlapping, and it's much more difficult to understand and read. So what we usually do, and especially if we try to plot on Excel, this is what Excel does this, and in some cases automatically, or in some of the cases we have to explicitly mention that please rotate the x-axis so we could make it more readable. In this particular case, so here it is, we try to rotate the x-axis here, and we give an angle on which we wanted to have a rotation. So once again, is it going fine so far? Any problem or any issue, any questions so far? Let's take some questions if you have, and otherwise we can move forward. Okay. So, any question for any person who wants to have? Okay. Okay, good. Okay, now let us talk about the axis of our plots. For instance, in this particular case, this is the graph which I get when I plot it. What it is, let me first quickly show you the data. How does it look like? Can someone have an intuition that what will be the data in this particular case? Please use your chat window to let me know that, like, what will be the values of the list in this particular case. Okay, why it's -5 to 4, Subhankar? Yeah, and the last value is 6 here, so it should be till 5, right? So it shouldn't. It will start from -5 and go till 5. So and now we want to have square of this list, in which we can do it like very easily. The thing which we have just seen, that how to do that, and then we have one more thing which is cube of it. We had seen that we were simply doing it like on the fly, and we were storing it on a different variable. We were computing it on the fly when we were plotting the data. But now we have another variable, and obviously you can go for the same thing, same way as well. But now plot says that this is sorry, your x-axis, and this is your y-axis, and this is again your x-axis, and this is your y-axis. So I think that it should be clear that why we have a graph like this, because like we have negative values, and for when we take care of negative values, it becomes positive. So if it is only uh, for square, it should be like this blue line, and if it is like for cube, for the negative values we have negative output, and for the positive value we have a positive output, and this is why we have such a trend. Now there are some important things here. Let us play with this splines or these axes, and what we do here is we use another function which is called GCA, and it basically stands for get current axis. So by axis I mean that we have these lines, and x-axis lines and y-axis lines and their border lines, and we can do some stuff. We can go for axis dot splines, and let me show you. So we went to the we access this splines or some this axis, which is stored now in AX, and we say that like on the right side set color equal to none, which means that it's there but it's not visible anymore. So if you want to get it disappeared, what we did is like we set a color to none. And similarly, we can go to the top, we can go to, and we can remove those axes. So here it is. Now we want, since like in this particular case, it's bit different sort of crop, and so it may get much more easy if we bring and if we move the axis uh, to different position. For example, in this particular case, you are saying that okay, uh, bring the bottom axis at this particular point. Let me show you how does it look like. Here it is. Now what we did here is we brought the x-axis from the bottom and we kept it at 0 index. So this is our 0 index. Similarly, we can also do with the left axis, and what we are doing is that in this particular case we may bring it into the center or actually on the point uh, at 0 where x and y both are 0. Here you go. So now we have axis in the middle. Fine. So far, any confusion here? Okay, good. So next, let us go and talk about legends. Does anyone know about what exactly a legend is? And I'm talking about like our graph legends and plotting legends. Does anyone has any intuition about it? Any idea? Yes, Nathan. What do you want me to explain? What exactly? Do you want me to repeat the question, or please let me know what is not clear, Nathan? This is question for Nathan. Okay, so let's go for and see GCA once again. So basically, so far what actually we were doing, we were seeing that the axis of our plots, and on axis we had seen that we can give the value to the x-axis, we can see, give the values to the y-axis, we can set limit, uh, we can, for instance, we had seen that like we wanted to go from 0 to 5, so we had set that particular limit. Python was taking it initially by default, and then we saw that how can we explicitly set it. Uh, and these exist for our plot. So what exactly we do here in this particular case, which is GCA, we access that particular axis, and we want to do some things with these axes. For instance, here when we had uh, this function here, so what we did is we we fetched the GCA, which means the axis of this plot, and we stored it in this particular value. And now we can apply a lot of different functions on this axis. Obviously, those functions should belongs to uh, the axis. So what actually we did two main things here. We removed some of the axis. We disappeared. Actually, they got disappeared because we set the color of those axes to none, and then we move the position of our axis. For the bottom axis, what we did here is that we brought the axis up a little bit, and actually on the axis 0 0. So by default, what exactly it was doing is it was starting from the first value of x and the first value of y, but we wanted to bring our axis to at the 0, x is equal to 0 and y is equal to 0. So in that case, like, we simply use the functions of axis. So we tell it like that what for what particular axis we are talking about. For example, in this particular case, we were talking about the x-axis, which is bottom axis, and we brought it up to y is equal to 0 here. And then we talked about this particular axis, and which is y-axis, and then we moved it towards x is equal to 0 here. So it's like just we access the axis and we played with it and just applied some different operations which we can to manipulate our axis of the plots. Is it clear? Sorry. Okay, good. Next we'll see legends, and let me just show you actually what legend is. So we had plot two main uh, lines here, the two main things. The first one was for square and the second one was for cube. Again, it's very difficult to and less intuitive and informative when we look at this graph and see that what a particular line belongs to. In this particular case, we want to explicitly tell that what blue lines belongs to and what orange lines belongs to. And so to do that, we always have these labels and legends. So let's see here, and here we are saying that okay, we are plotting a thing which is on x-axis we have data, we have y-axis we have also have data, but what that data belongs to, in this particular case it's square, and then we have for another line we say that it is cube. So we just want to appear want this particular legends to appear, and for that we have this particular function which is a plt of legend. So it will simply display the legends or the labels of that particular lines. So here you can see that it is square and cube. Okay, is it clear so far? If yes, then it's a little different topic. So if you have any questions so far, we can just have the Q&A session, and then we can have a small break before going to the next thing, which is a little bit different, a little more information. Obviously, we start from the basic thing and then we evolve and incorporate a little bit more complex things. So the question is everything is fine? Okay, it's good. Any questions? Anyone? Okay, good. Then let us take a quick break of 5 minutes. And meanwhile, if you have any questions, please let me know. Otherwise, let's take a break of 5 minutes and see you in 5 minutes. Yeah. So is everyone back? Please give me a quick thumbs up using your chat window to say that you're here, and so we can continue. Okay. Missing a couple of more yes. Okay. So let us start. I'm not sure if everyone is here, but there are quite a possible options or ways in which you would like to have multiple figures beside each other, and because in the not only multiple lines within a particular plot but multiple figures. We'll see an example there that how can we have it. For instance, now let's first take some value, and let me just show you that what the data looks like. X-axis, there's a value starting from 0 with pi, mathematical pi, which is we take using numpy, and these are the values. And then we have y, and then what we do is that we take subplots in this particular case. So subplot is a function which returns us two main important things. First one is the figure, and the second one is the axis. I'll show you that what exactly axis looks like and what exactly axis is. So in this particular case, we use the x-axis of this particular function, which is line space starting from 0 to 2 into n pi, and 2 into numpis of pi, and then we use subplot and we get an axis, and axis is of x and y. I'll further let you know that what are the different options we can have in axis and how can we play with it. So here we simply then can set a title of the plot, and this is actually the plot for us. But this is the important thing is this is a subplot. What I mean by subplot, what else we can do with subplots, let me just show you. Here we have another subplot. Put it for the moment. So here you can see that now we have multiple plots within a figure, and these are called subplots because like it's like subplot of our major main plot. In this case, we called a function subplot, and we again had have got two outputs. Output is composed of two main parts. The first one is the figure, and the second one is the axis. So, and then we set uh, the axis of plot for the first one, and here ax1 refers to the first value. Can someone tell me, can someone guess from this context that what is 1 and 2? Okay, so Vijay is saying x and y. Any other intuition here? What do you think this x and y is? I mean that what does this 1 and 2 refers to? So it's not that difficult then. For instance, this is just an intuition, and it is that like we want to have subplots, but how many? So we want to have one row and two columns, which means that like in our output, what the figures we want to have should have like one row and two columns, which means that like this will be the number of subplots in our figure. So here, this is why this goes for the main figure, and then we have two subplots. The first one is we just name them. It can this is just a name. It can be any name. So for axis one and axis two, and then we set some properties of axis one. How we want to plot it x y, and set the plot. X and y is the data which we just took up, which we had seen. Let me just cross see, check it and see, show it. Yeah, so this is the x and this is the y, and then we want to have a title of this particular subplot, which is line plot. And then now, because we are going to have two main subplots, so we can have any other plot with any other data, and any other data, any other plot type. In this particular case, we are going to a scatter plot. So here you can see that like we have a scatter plot beside each other. And now a very important thing here is which can be really informative and very useful in a lot of different cases. And so here we are repeating the y axis actually. I'm sorry. So actually we are plotting the same stuff, but this y-axis is being repeated a lot, two times. And imagine that like if we have multiple subplots, it will be repeated for all of them. So we have another parameter which says that you want to share the y-axis. So let me show you what happens. So now this y-axis is shared, so it is not appearing again here. Instead of like wasting space, what we can see that like we can have the shared y-axis, which means that y-axis appeared only once in the start of the first plot, and then for the rest of the plots it does not appear. And if you have to find out like that, okay, what a particular value belongs to, so you have to refer to this axis. So let's move forward. Similarly, we can do a lot of different stuff. In this particular case, we want to go for two rows and two columns, which means then in total four axes. And then for now, in this case, we get figures and the axis. So axis can be called using this like the corresponding index. So it's like 0 row, 0 column, and 0 row, 1 column, and the first row, and the 0th column, and the first row, and the first column. And then we can use the corresponding different parameters to further set it. In this particular case, the actual one was the basic knife line graph by default one, and then we have R is for red, and then the type of line, and then we had another one on the first row, zeroth column, with green and this particular symbol, hat symbol, for our ticks or our data points, and then we have another scatter plot. Similarly, you can go for more number of figures or subplots. So, so we had seen a thing that, like, we just shared y-axis. There's another option that, like, when you go for multiple rows, you can always share x-axis as well. So in this particular case, important thing to know is that, look, we took four different figures, but we didn't plot anything. So it's quite possible that you take space of all of these things, but you don't plot anything. And if you want to plot anything, you have to do the similar way as as we have seen earlier. That whatever you want to plot, you can go for that. So you can call that particular part of your subplot or figure, and then you can plot using the corresponding suitable parameters. And in this particular case, now we wanted to, because we had share multiple rows, so we could share x-axis, and it is just like in this particular case, so our x-axis is not repeated. It is only for the bottom row, and whenever we have to refer, we can just go and see that what a particular data point belongs to at the x-axis. So next, similarly, we have seen an example of shear at y-axis, so we can always shear it. And for instance, in this particular case, so y-axis is here. We have seen an example of this as well. You can always share both axes. So here it is. So by share x all, there are two possible ways to make it. Either you can make it true, which means that we want to share our x-axis, and if share y is true, which means that share y-axis is true. And there is another option, if you also write all, it also means same, that we want to share the axis. Yes, and then important thing which we were doing here is that we were basically taking the figure and we were plotting each and everything at a time. So once we know that where we have to plot our subplot, so we can plot them, and we can plot the figures and graph one by one. So just to cross check, is this subplots thing clear, and this share x and share y? Yes, Shubhankar. His question is, can we get different graphs and subplots with different values? Yes, we can definitely have different values, different inputs, different x-axis, different y-axis in subplots. So this is the basic purpose of subplots. And just for the simplicity, we took it like that, that we only took the same data and we did it for subplots. But obviously, you can go for different data and different types of graph. For the different type of graphs, at least we have seen it here. For instance, here you can see that these are different types of plot, but we had the same data, but it could always go like beyond that, and we can have a different data as well. Any other question? Okay, then let's move forward with this. Now, there is another way. Actually, what exactly we were doing is that, let me just compare it. So we were Here it is. So what we were doing is that we were taking this, we were running this function which was returning a few main things. The first one is the figure, the second one is axis, and then we were calling that axis to plot it, our figure which we want to appear in that particular subplot. Now, another way of doing this is that we can just give the number, which is that number of in this particular subplot. We can say that these we can input these three parameters. The first one is the number of rows, the second one is the number of columns, and the third one is the figure number. So obviously the total number of figures will be the number of rows into number of columns. So for instance, in this particular case, we want to have two rows, and this is our first column, and this is for yes, and this is our first figure. So it means that two rows, and this is only one column, and this is our first row, first figure, and we want to plot this particular thing here. Let us just plot one. We can append one more subplot here. To do that, what we'll do is that again two rows, one column, and we want to have it as a second, appear it as a second figure. Here it appeared, and but what exactly we want to plot it, we can always use a plot function for that. Another thing, can someone guess that what will happen here in this case? So now we want to go for two rows and one column, and we want to plot it at this particular thing at third place. Can someone let me know? Think about it. What will happen in this particular case? Any intuition? By the way, do you understand that what exactly is going on here? Yeah, Abhishek is saying error. Why? Why, Abhishek? Can you please briefly tell us? Exactly. So our total figures are less than this. So yes. So here we have an error. Why? Because we said that we want to have two rows and one column, which means that in total we can only have two figures. But we want to plot it as a third figure, which is not possible. So this is why I threw an error. Okay, if we want this, we can go for the third one, and now we are going for three rows and one column. And so this the first one will be the first figure for that. Second one is the second. Third one is for the third. Similarly, another example. Now we just increase the number of columns, and it says that like two rows, two column on the first figure. So on the second one is this one on the right, and then similarly third and fourth. Okay, and now let us go and see our actual data set, which we have been using for a while now. It is a data set of delivery. Just to give you a recap, and whatever we do on each delivery, how much we score was made on that particular ball, who was the batting team, who was the bowling team, who threw the ball, who was the bowler, who played it, who was the striker, and who was the non-striker, and all of this information is given in this particular data frame. Now we want to do some analytics on real data stuff and see that how can we visualize it. So we want to find out the batsman run, and among them we want to select like some of the largest one. And what exactly we do here is that we group by using batsmen and use the batsman run and simply sum them, and that's the top 10 batsmen out of it. Let me show you that how what exactly do we get in this case. Here it is. Can someone tell me that if there is another way of getting top 10 batsmen here other than using this n largest? Exactly. So we can always sort it in a descending order and we can take top 10 out of it. So, so in this case, we simply use this function and get top 10. And now let us plot. Okay. So here in this case, what exactly we did is that we plotted the output of this particular line of code, and which was stored in batsman. And what exactly data do we have? Let me just show you once again. So we have batsman in the first column, and the corresponding scores in the second column. And if we plot it, what exactly happens is that Python takes the first column as your x-axis, and then the total number of scores as a y-axis. And then we did this rotation just to have a clear reading of x-axis, because the names are pretty long and it would be difficult and they will be overlapping if we don't do rotation. So clear? Let's try to do one more thing here, and in this particular case we are going to do the bar chart. Now we have seen so far the line chart. Now we wanted to go for bar chart. Here an important thing is that we may write our code into multiple lines, but to let Python know, we use this escape character, which is backslash, and which means that like our code is not finished yet, so it is going to the next line as well. So in this case, I am sure that you are pretty familiar with this syntax and you know that how to fetch top 10. This is what we have been doing for a while now. And then we want to go for plot. In plot, we tell that what is the type of plot, which was initially by default line plot. Now we are going for bar plot. And then we say that what is the title of our graph or our plot, which is top batsman. And then do you want to rotate the x-axis, the labels of x-axis, and the color of the plot. So this is the output in this case for us. And after that, one more thing is we go for, let's create a new data frame. So in this particular case, we have created a new data frame, which is composed of these 4 columns and random values of 10 rows and 4 columns. And let's go further with this. Now we want to plot, and actually there are 2 different types of plotting bar graph or any particular type of graph. One is that which we had just seen, that we give that what is the kind of plot, and another one is that we can use the corresponding function. But now an important thing which you have noticed is that we are not calling the MATLAB library. We are calling the pandas library of plot. So here, for instance, what actually we were doing earlier, we were using the plt.show and plt.plot before this pandas library. So here, this was PLT, which was matplotlib library, but now we are simply calling a function of data frame. For instance, here you can see that this particular function, which is simply a function of this particular data frame, because in this particular case, if we see that what is the type of uh, batsman. So here you can see it's a series, like just one column of the data frame, and we called a plot on this because it belongs to one of the function of this. And then so here once again we created a new data frame, and then we wanted to have a plot, bar plot. So the good thing is that like we have multiple columns here, and then when we plotted them, we simply all of these columns for all of these values for particular columns were kept together to have a better comparison among them. Uh, Another type of plot which you probably have seen while plotting different stuff is that this stacked bar graph. In this particular case, what actually happened is that uh, you actually stack the whole column on top of each other. For instance, in this particular case, we had four different columns A, B, C, D for value 0. So we had four different bar plots. Now we want to stack on top of each other. Which what will happen, like first we will have on column A, then B, and then column C, and then D on top of each other. There are a lot of different applications of such a bar plot. For instance, an example could be like if you want to see that how many score a particular team has made in an inning, and what was the major contribution for a particular guy in total. So what will happen is that like if you plot the score of all the batsmen and put them like stack them on top of each other, so you can always see that what a particular portion belongs to which particular player. Based on that, you can have your own insights and analysis. And yes, you can rotate it as well, just to now previously it was like properly vertical in a vertical way. Now you can always go for horizontal. To do that, it's not that difficult. What you can do is that you can just use plot dot bar h, which is bar horizontal, and obviously stack should be true for this. Then this is just a color map. Is it going fine so far? Any question? Okay, so then let's see with another example actually, and I think that we have seen this example earlier as well, in which we wanted to compare the scores between two seasons, but that was for one particular team. Now we are going for a particular batsman. So to do that, what exactly we use is a couple of things. For example, we are using merge and uh, some new things which you may not have seen now, but it will be after the visualization part. That what exactly is merge for? How do we do joins on on different data frames? And, so basically, the only purpose is let me just show you that what exactly the data looks like, and then how then we'll see that how to plot it. Let me show you exactly this IPL here. So this is our main data. Actually, we are combining two different data frames based on this ID and match ID, and in this particular column. Anyhow, and then we want to have comparisons of runs. What does it look like this? For a particular player, we have for different seasons we have corresponding different runs. Okay, so finally we have this data frame which has like the batsman runs and the batsman name and with the corresponding season which they made. Now let us play with it and let us see that how to plot it. So in this particular case, what we did here is that we simply took batsman comparison and plot dot bar, so which means that we are interested in batsman in a bar plot. But look at this. The problem is that it took the first column as an index, the index column as a x-axis. So it's not really intuitive for us to understand that what does 2 belongs to and which particular batsman it belongs to. Now let's see what exactly we can do here to solve such an issue. We can go for pivot, and what pivot does for us here. So it changed our data and it tells us, let me just show you first that what does pivot look like. So if you have seen a difference here, now we have our main column is batsman, and our season column, which was like his here, we had this multiple rows on season. Now this has become uh, column in our new case when we applied a pivot operation. We will further see pivot operation again when we will be in like after this two sessions of visualization. So don't worry about it. For the moment, we have seen like that like there is a change in our data frame, and now the season become uh, the column, and now we have the scores of each and every batsman beside each other. Next, we simply plot it using bar graph, and we have a color map. Uh, this is how it is. It's much more intuitive that what a particular value belongs to which particular batsman and how much scores he made in comparison of these two different seasons. So yes, and another important part, the reported type of graph is pie chart. And in this pie chart, what exactly we have? We basically have a circle which is divided based on 360 degrees, and then our portion tells us that what a particular uh, part of your data, the percentage of a particular part of your data. For instance, in this case, we want to see that which team won so many matches, and here we have this is the number of matches, And so here it is. Let me break this code down for you. So explode is like just to explode the main thing for you. Let me just quickly do this. So we have an empty plot. We want to, yes. So here it is. So basically, what exactly we want to plot here is that match winners, and that what exactly match winners is. This is what we are getting, like which is number of the matches and the number of values of winner a particular team, the number of matches a particular team has won. So this is what we want to plot here in our pie graph. And then what are the labels? We don't want to have a label here. And then what is the percentage of that particular team, the number of matches of that particular team who has which has won, and how does the data should look like. And this is just tell us that like we should have like float digits up to one particular value. So you can further go into the documentation to see that how what exactly a particular value belongs to here. And then we can tell that at what particular angle you want to start, like for instance, like should it be right on the straight line here, which is like 90%, 90 sorry 90 degree. And so do you want it like from right from the, the 90-degree angle, means that here, and it will go in this particular way, like anti-clockwise. And then do you want to have shadow of this? uh, no. And then you want to further explode it. By exploding it means that it will like take apart and out and show it like that, this is to highlight that particular thing. In this particular case, just to give you an example, let me explode it a bit more. So here you can see that for this Mumbai Indians, I've exploded it, and the rest of the things are like still there. And so, but an important thing to note here is that if you want to explode one of them, so you have to do it. You have to give 0 for all other things. Otherwise, it won't work. It will throw an exception. So in this particular case, we just bring this Mumbai Indians out of it, and, and let me see that if we explode all of those. So this is how it looks like. Uh, is it clear? Any confusion here? Okay, that's good. Anyone who has any confusions or any questions so far? It might be a bit overwhelming because we're covering a lot of different types of graphs, and in case you are not familiar with all of these types, so it may be a bit overwhelming. Otherwise, it's pretty nice. But the good thing is you can always do the practice and using your assignment, and it will help you to have your hands on it. But anyhow, coming back to the thing that any more questions or any more things which need more clarity, so we can go it and revise that again. Okay, so if no more question, then can someone tell me that what is a histogram and why do we use it? So does anyone know that what is a histogram? Kindly reply on that. So okay, Akshay is saying area give you the value. And why do we use it? So basic purpose of let me just let you know. The basic purpose of histogram is to see the distribution of your data. By distribution of your data, I means that like how exactly your data is distributed. For instance, that uh, if I talk about the number of runs of a one particular team that they made during their batting time, and so how many people made score under 10, and how many people went into the between 10 to 20, and so on and so forth. Like how many people were in between like 20 to 30. So let me just show you, and it will be much more clear after that. For instance, in this case, we are saying that let me just quickly show you that how does it look like. So in this particular case, it says that like matches, and matches are win by wickets. So here we have an index, and like we are only interested in which like matches are won by wickets, which is not zero. So in that case, this is the graph for us, and for this particular index, we have the output is 9, and then we for this particular index we have 5, and so on and so forth. Now when we try to plot histogram of it, so what actually happened is it's tried to identify a range. We called it bin, uh, and and for each bin, like for instance, it's like taking from 0 to 2, and 2 to 3, and 3 to 4, and 4 to 5, and it is trying to count all the values that which lie in this particular range. For instance, from 0 to 2, if there is probably there is only couple of matches in which they they won by uh, uh, this many runs. So similarly for each and every other bin, you count it, and this is like this tells us the frequency about it. So this is it. Yeah. So is it clear that what exactly we are doing? I'm not sure that how much are familiar with this histogram, but this is about like as I said earlier, that this is basically to show the distribution of our data, that how does our data is distributed. So here you can see that like with how many oh, like what is the margin of winning of the teams in this particular case. So is it clear? Can we move forward? Let us see that about the winning. If we want to find out that how many runs usually team win and in IPL. So this is what we do. Like we say that matches win by runs, which is not equal to zero, which means we do not want to cover the other time when they were not batting first. And in this case, this is the output for us. Like for the zeroth match, they won by 140 runs and so on and so forth. And it's difficult, very difficult for us to follow that. Like how many people, in this particular case, that how many people won the the matches between like 0 to 10 and 10 to 20 if we do it, and it, obviously we can group by and see it, but it's much more intuitive if we apply histogram and see it in the form of histogram. In this case, for instance, here you can very quickly see that like most of the times match uh, the match were won with by only like up to 15 runs. Now we have these wins between like 0 to 10 and 10 to 20 and so on and so forth. So the default values of pins is 10, but we can always have a different pin size. For instance, here in this particular saying that in this particular line of code, you are saying that we want to have 40 different pins. By bin, again, it's like a range in which you are counting the frequency the number of items for your for your corresponding query. Here in this case we have 40 pins. Okay, so then the issue is happening here is that like it is building both of these graphs on top of it. Let me just commit first one, and here it is. Now we can increase the number of pins, but then it will become less intuitive. For instance, here it will more or less like so for each and every point you are telling that that how many matches were won. So the important and the suitable value is that we need to find an optimal value for the number of wins based on our data. So I think that like if we go for 10, it should be pretty good in this case. Okay, so is it clear so far? Any problem? Okay, so if you don't have any question, let us take a break of 10 minutes and then we'll start in like 10 minutes. I'm here. Please let me know if you have any questions. So is everyone back? Can we continue? Okay, Abhishek. Any other persons who are here now? Okay, okay. Okay, so let us start. Now I'll talk about another type of plot basically, and first of all, let me just show you take a random data set and describe it. We had seen this function before, so I won't be going into that much detail. Just a quick overview that we have created uh, a data frame of 10 into 5 10 rows, 5 column, and then we are going to describe it. By describe, I mean that we have a set of different parameters on which we evaluate each and every column. For instance, that how many values are there. For that, we have count, we have mean, which is average, we have standard deviation, we have the minimum value in our column, we have the first quartile, which is 25%, we have second quartile, which is 50%, we have 75%, and we had max. But the problem with such a table or such a representation is that it is full of numbers, and it's very difficult as a human to interpret these numbers. In like, imagine that like this is just like 10 into 5 table. You are going to get, like, for especially big tables and big data frames, it will be hundreds of columns and hundreds of rows. And obviously it can go to millions as well. But anyhow, the point is that it's very difficult to interpret and understand that what is going on by if we only focus on these numbers. So for that, we have different ways to analyze to see the data, and one of them, which is like highly used by a lot of people, is box plot. Let me first show you what how does a box plot look like. Does anyone of you know what box plot is, or anyone has ever used it? Okay. Okay, so let me first show you how does box plot look like, and then I'll tell you that what does it really mean and what a particular thing in box plot should. So here it looks like these boxes, and here you can see that one particular this figure, which is saying that like started at zero. Basically, this is for zeroth column. So for each and every column and for each and every value, which is like here in this describe column, we create a figure, and this figure is called box plot. And for instance, consider this first figure, which is from zero at like column zero. So let us start from the here, and the first this line shows the minimum value of that particular column. Then the second, this box shows the quartiles. So this is the first quartile, which is like what is the value at 25%. If you sort your data, so first quartile, we had discussed this quartile. I believe that everyone knows. If you know, if don't, we can give it a try as well. And now again. So what you do, you sort your data. The first quartile then is like at a 25%. So what is the value at the first 25%? And then you want to see that how it is distributed further. What is the value at the second uh, at the second quartile and the third quartile as well. So and then what is the maximum value in that particular column. And so this is like how now for each and every column we can very easily see that like what is the minimum value, what is the maximum value, with most of the values lie at which quartile. It's just in like 25% range if it is in median, uh, or like the third quartile are 75% at a 75%. Similarly, it also identifies some of the outliers for us. So for instance, here you can see that this point is an outlier, and so on and so forth. Like it's just, and just try to compare these two tables. So here, from without visualization, it's much more difficult to follow. But here, when very quickly we can see that okay, what does upper range, what does a particular point lie in which range, and what is the minimum value, and what's the maximum value, and your mean values as well. So in total, we have uh, basically five main things. Each block depicts the median, 25th, as I mentioned here, 25th percentile, and similarly for the other percentiles as well. Is it clear? Did you get what I meant by box plot and how can we use it? Okay. Okay, so a good way to do a little. Okay, so Sandeep is saying that can you do? Can we try to go through it again? Yes, for sure we can. So basically, box plot is a way to represent our data, and what sort of data? Like in a lot of cases, we want to see that how our data is distributed. One of the example which I just mentioned is is the score of our batting team. So we want to see that who is where is actually the problem, or who is performing well, or like how does uh, our data looks like in for one particular team. So what we will do is that we will find all of the scores of batsmen, and we'll try to make a box plot and out of it, like based, even if we talk about one particular uh, user, let's say that like there is a new player, and we want to see that like how he has been performing in past. So we want to see that like uh, what is his average score, how many times like he has been doing less than average, how many times he has been doing more than average, what is the minimum score, what is the maximum score. So we want to have a like uh, overall glimpse of the idea that how does it look like. So there are a lot of different ways to have this. For instance, one of the thing I had shown you is the histogram. But in this particular case, we had seen this particular function earlier. Let me just show you once again that we have created a data frame using uh, in this particular data frame. This was created using random integers, and let me just show you. But now I want to know that what this particular column, what is the distribution of data in this particular column. So what is the average in which particular domain, in which particular range a particular item or particular value lies. So to do that, we had a function df.describe, and this tells us about this thing. So for example, it tells us for the one particular column, this is the mean value, this is the standard deviation, this is the minimum value, this is uh, this is a 25% value, or if we sort our data, so this will be our first quartile, and this will be the median value, which is like second quartile, and then 75 is our third quartile, and then finally we have the maximum value. So we can plot this information using box plot. By box plot, what exactly it does for us is basically uh, give us a figure, sort of this just like this particular figure, and it is composed of two endpoints. One is the minimum value in this horizontal line, and then we have this particular value, which is the, which is the maximum value in this case. In this particular case, we just wanna Yeah. So in this particular case, like we just represent using this figure all of this our information. The first one is like as I say that like the minimum and the maximum value, and then we so here we can see that like most of our values will lie this in this particular range of in this quartile. So this is our like starting from 25% to the 75%, like our data will lie in this particular range. So this is the our mean value as well. So this is just about a distribution of data, and you can see that like a how where exactly a particular data point should belong to. For instance, that if I assume that this is the score of a new guy who has a potential to be in our international team. So what I will do is like I will see that okay, what is his minimum score and how many times he has been in this particular range. Like for example, what is his average score, and what was it between like 25 to 75% time, what in what particular range it was, and then about maximum score, and obviously we can ignore outliers as well in this particular case. So did it make much more sense? Actually, it's like a concept. I am not sure if we can go into real detail of this about like what exactly the quartiles are, and if you really want to go into much more detail, then maybe you have to go and check a little bit on the internet as well. But for the thing is as far as box plot are concerned, so this basically is used to distribute to show us the distribution of that data. But is it clear enough, or if you have any problem in that case, so please identify that what exactly you want me to discuss more. So Sandeep, is it clear? Is it better now? Okay. Okay, but if you still have any questions, we still do have some time to discuss, so we can spend some more time on it. Okay, then we can move further, and we can see another example in which we are trying to find out. Let me show you one by one, and let me break down the code. A no average shouldn't be in the center. So this is actually a very good point. Uh, average average basically we have two different measures for it. One is average and one is median. Usually we have median, and median is the middle point. Average can be on the any side, right? If you have 10 different values, so average is not always in the middle, right, Vijay? Is it clear? I think that you are mixing it median with average. Just imagine that if you want to find out like average of income of a particular country, so there will be a lot of people with like limited salary, and then there will be a king in so-called those kingdoms, and kingdoms amount is her income is much more than a normal person. So if we take average, it will be biased. It will be towards that king's income, right? It won't be in the middle. So average is basically in the middle when you have almost the same values, right? So it will then in that particular case, or it's like it goes or it is increasing constantly. Then we have it in the middle. Like if you take like average of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it will be somewhere like in the middle. But if we have multiple values within less than 5, and then few values greater than 10, so obviously it will be a little bit at a different point. So, but for median is the middle value actually. If we sort all the values, then the middle value is the median. Okay, so let us move forward, and let me first break down this code for you, and we can go further. So deliveries data set and group by match ID and batting team, and we are calling them total runs, and we are summing up that scores, and we are resetting index in this case. Let me just print it. So here we have all the teams and their score. We want to find out top teams, basically grouping by batting team, total runs, and largest five, and converting it to list. These are the top five teams, and we want to fetch it from the team score where they belongs to this particular team. I am sure that it won't be that much difficult for you because this is normal pandas thingy. So now we have match ID, batting team, and total runs they have made. Let me see that how does it look like if we try to have a box plot of that such a value. So here it is. Now, so now for each and every team we have seen like a box plot, and this box plot shows that for instance it talks about the total runs, and to see that like where does it lie, at what particular quartile it lie, what's the minimum value, what are the outliers, and where exactly it was in this what was the mean and your 25% quartile and 75% quartile. And it goes for but the main problem was that in this particular case we had a lot of teams and everything is coming one after another one. But actually it would be good by if we put them beside each other so we can, okay, yeah, so we can actually, if we have to compare with, we have to put them beside each other. So in this particular case, we, for each and every team we have a box plot and we see that how many runs were made and like at what particular range they were, and then after comparing it with, we can see that like who is winning in most cases. So we had seen that like Chennai won most of the matches, and here you can see that their score distribution then is better than the other one. So with this, then we have one more thing, a type of plot which is called area plot, and again we have a data frame. What exactly we do here, let me just quickly show you. We have this data frame, we want to compute, uh, so like we want to keep it in 100. What exactly we do is we take sum of across rows, and we divide it each and every cell by the total value. For instance, like it is 45 plus 14 plus 6 divide, so for the 45 divided by the sum of all the values. And let me just comment it off so it does not create another value because it's a random function. So then this is what it is now. So it tells us like some what is the percentage of this particular value among these rows, so what percentage it is. And now we're going to do this plot which is of type kind area, and the stack is true. Let me show you that how does it look like. This is how it is in total. To avoid confusion, let us take this value first. So here in this case, now we just simply stacked up the things, and this is an area plot. So we have three columns, a 0 1 2, and so first of all we had 0, then we had 1 here, which is of orange color, and then we have green color, we have 2, and this is just moving with the values there. But the thing is that think about here, the value was actually 34, 13, and 36, but here the value is going up to 80. Why? Because they are stacked up on each other. So to have a better idea, like if I want to find out that okay, what was the percentage of green here and what is the percentage of this orange and blue, so what exactly I can do is I can try to find their percentage accordingly uh, in their data frames. So here in this case, now I fetched percentage, and now I will plot the percentage of this. So here it is. So now the total value is 100 because now we are talking about percentage. Is it clear? Can we move forward? Any anyone who has some confusions with it? Okay, then let us go for one more thing. I'll go again step by step and see that what does data contain. Let us first go for this. So our main IPL data, again that we did merge on the IDs, match IDs, and let me show you how this group look like. It's like season, batting team, and their total run. We further do pivot, which we had seen earlier, that like seasons and is one of the column, but with different values. We want to bring this in column. For each season, we have now uh, different set of values for each and every team, that how many scores they have made in a season accordingly. So then we want to find out that okay, what percentage of runs they were made by, for example, in season 2008. So the Chennai Super Kings made in total 2,520 runs. Delhi made 2,118 runs, and so on and so forth. Now, but want to find out what percentage of score was made by Chennai, the percentage of total scores which was made in a season of IPL on 2008. So what was the total percentage made by Chennai? Okay, so what exactly we will do is we will simply sum up all of these values and divide each and every column by that sum, and we'll get a percentage. So for instance here, let me show you. So here it is. So it's like approximately 22.5% runs were made by Chennai Super Kings. Let us try to plot it, and here it is. So here is an area plot, and here you can see that okay. So this blue color shows Chennai Super King, and here you can see that like for some reasons like their total scores went to zero in 2016, and the reason was that like there was no Chennai Super Kings in 2016. So but like then overall it can show you that like how much scores they made in every year. So such sort of things can help you out to identify that if there are any anomaly. For example, in this case you can see that there was something wrong in 2016 because the score went really to zero. And we can see one more trend that for some reasons like their average was like their percentage was decreasing in 2016. Look at this for every team. So let us. Any question here? Okay, if no question, we can do for one more thing. Now we have matches and dot plot. And kind it's scatter plot. Scatter plot is the plot in which like we scatter the values of the text based on the value where they come from. And we have seasons and y runs. So what exactly we did? We have a season on x-axis. We simply say that x is season, the column x is the column season is x, and column y is win by runs. So here we have win by runs, and here we can see that like in 2008 which matches were played, and for how many runs they were won. So one of the match was won by 140 runs. I'm not sure what happened at that particular match, but most of the matches the winning score lies in between like 0 to 20. So any questions so far? Otherwise, we can go a quick recap of what we have covered today. But before doing that, please let me know if you have any question. What is fixed size? Okay, so that just tell us about like the overall size of the figure. Let's try to. This is a good question. Actually, let's try to change it. So it will just about the size of this particular figure, that how big it should be. Like let's make it 10 into 10. So it is square now. That like eh, let me just ignore this thing. So this is the default size, which Python based on the what contents do you have in it will make it, and like but like in some of the cases we want to enlarge the size and see that okay, uh, this is a really important data and we want to go for it, and we want to further. Yeah. So this is just about the size of a figure, that how much it should be. Go further. Nothing that technical. So if you just want to change the size of your figure, you can use such a parameter. Otherwise, like Python will take it default by default a size. So any other question? Okay, then let's do a quick recap. So basically, we started today about visualization, which was and we had seen a library called Matplotlib. First of all, we see that like how to put it in online using this particular new thing which you hadn't seen before, and then we went for the basic lines. We had seen that how to draw a basic line, and we know that by default it's a line graph. And after that, we saw multiple uh, some manipulation with the axis, that and the type of the graphs. We can go for a line. We can have different types of picks and values. It can different colors. We played a bit with axis, that uh, how to control those axes, how to control limits, how to control um, the labels or the labels of graph, and the width of lines, etc. And then we had seen about having grids on the back of our graph, which will much more intuitive if you want to find out at one particular place that okay, where your data is. And then we had seen then how to annotate it. Then yeah, again we had seen another way to limit our access. We saw about ticks, that depends how many ticks do you want to have for your graph. We had seen a way to rotate the labels in the text label, and in this case like when it's not readable and the labels are too large to avoid overlapping. Then we had seen splines, which was about axis, that we played a little bit with axis, that we removed some of the axis, we moved axis from one place to another place. We can change the color to different things of these axes. We had seen some legends, that to give some values to this, like to show that what exactly a particular lines belongs to, and just to give a label to that lines are in the form of text to make it more readable and intuitive. We had seen multiple figures and axis. Here we had seen about subplots. Later we saw about sharing axis of both x and y axis. Then we saw the library of pandas for building for visualization. We had seen line plot, we had seen bar plot, stacked bar plots in a horizontal way. We had seen we had covered this merge and pivot thing, but not into the detail. But the rest of the thing is like pretty pandas query, in which you can just manipulate data. And then we had seen that how does it look like if we apply it on our real data. With the we try to visualize in the form of bar graph. We then we had pie graph. We had seen different ways like how to explode it. how to zoom it, one of the things to make it much more intuitive. We had seen different ways to have the distribution of our data. One is the histogram. Another one was the box plot, in which we see that a lot of different details of our data. And then we had seen area plot, that how does it look like if we are stacking on top of each other. So it tells us that how it evolves with your x-axis, and covers up shows the portion of one of your main team or attribute, whatever you have. For example, in this particular case, you see that like the area of green, this green area increased with the passage of time. So here it was like little bit here, and then increase the overall area of the green. So yeah, and then finally we had seen a scatter plot. So with this, like once again, I am available for the questions. If you have any questions, please let me know. If no, then please go to this feedback link, and don't forget to provide feedback. So it will help me to bring some more improvement if it's really required. And once again, if you have any more questions, do let me know. Otherwise, I think that that's it for today. We can leave the session, but I'll be here until for a few more minutes. So in case you have some more questions, do let me know. Otherwise, like thank you very much for today's session. Thank you everybody. Yes, Sandeep. Yes, Sandeep. Go ahead. Do you have any question? You can or you cannot. Okay, this is strange. I didn't know about that. I think like drop an email to the guys, Rahul or the guy. Okay. Do you have any question? Like I don't know. What's your question? Like answer shouldn't be there, and they are there. And what exactly you want me to verify? Yeah, then probably there is some mistake. If they probably uploaded the wrong file there. Or just send an email to them that this is what happened. So probably I am not really sure. There are different teams who works on assignment, but if it's not a usual practice, then I'm sure that this is just a problem, just done by mistake. So just let them know. I'll also let them know that like the assignment was with answers there. So welcome. Thanks a lot, Akshay.